I'm Max Clark. I just finished recording with Jay Smith of Evocative Data Centers. Jay's been in the data center business for over 20 years and has seen a lot in that span of time. We talk about data centers, how Evocative is building, what they're looking for in facilities, how they're approaching customers, what they're seeing in terms of customer demand between traditional users and the AI and ML explosion of density requirements that comes along, how Evocative is pushed into bare metal, how customers are consuming bare metal, cost structures related to data center bare metal over cloud, and some interesting predictions at the very end. It's worth hanging around and catching the tail of this. Hope you enjoy it. When this is a tech deep dive, I'm joined with Jay Smith, who is now the VP of Business Development with Evocative Data Centers. Jay has been involved in the data center world for a long time. I'm not going to call you out directly, Jay. I'm going to let you call yourself out for how long you've been in this crazy business and this crazy world. And we were chatting a little bit beforehand about how you've also transitioned out of an operational role into the other side of the house, which is good and bad, but first and foremost, thank you for volunteering to do this and for the conversation.
Thanks for having me. It's great to reconnect and kind of talk through things, how they are now versus the way they were 2 decades ago. So,
there you go, 2 decades.
I'll leave it at that. It's actually probably closer to 3, but we'll leave it at 2.
It's longer than 2 decades, Jay. I've known you for longer than that. So let's start with a little background on Evocative, and actually we can kind of go back to inception, right? How you got into data centers and how that has transformed along the time into what Evocative is now. So we don't need to hit every highs and lows, but that means we're going to start back in the 90s sometime, probably.
90s, I went to work for a very old family friend, and for the next 21 years, he and I ran a little boutique colo data center in Southern California, expanded into Phoenix and Dallas, and he moved to retire. And so we sold the entity to Evocative, and we were part of a series of acquisitions that took place over the last 7 years. And I came on board, and we kept growing the company, and through a series of additional acquisitions up through last year. The biggest one being when we acquired the co-location of data center assets from Internet. I did operations and kept rolling through and doing salesy things on the side and helping the sales team. And I pivoted out of that role and into business development really last year. So it's been roughly 12 months now I've been in the seat. We keep growing. We keep finding new data centers and expanding our operations and adding staff, new facilities in new markets and same markets we're in.
So in the course of the last 25 years from your seat, from an operator, there's companies out in market building data centers, and these are the hyperscaler, I really don't like that term, but these are the hyperscale campuses where you see 100 plus megawatt projects going in. But what surprises me always is the longevity of data center assets. And facilities that were built in the 90s are still running today. And I know of several that actually have my blood under floor tiles, where we did the initial installations in the late 90s, and they're still going. They've traded names a bunch of times, but they're still there. So how, from an operator side, and now as you're looking at acquiring facilities, how do you think about this market, and what are you really looking for, and how do you evaluate geographies and facilities, and what makes an interesting acquisition target, and how do you navigate these waters? Because you're not in the business of building data centers, you're in the business of really buying and running data centers.
Well, I would say in my pivot last year, right, I stepped away from that role, and I'm not privy to what's in the pipeline per se. In this day and age, we're looking to add to the portfolio, and we're focusing on not just facilities that we can acquire that have a base, but that we can expand in, whether it's from a real estate perspective or a power perspective or a retrofit perspective. So that's kind of, there are a lot of different options available in the market. And again, I'm sort of out of that role now, so I really don't know what we're really after. But I know the team is working to add to the portfolio that we have today.
Data centers, so there was a big push to build data centers in the late 90s. .coms, really this expansion of the internet. That tracked forward into mid-2000s, and then we had the dawn of AWS and really this idea of what we see as cloud computing today, right? And then around that time, there became a lot of predictions from certain people of data centers were dead. And it doesn't feel like the data centers are anywhere close to being dead in the 15 years since that prediction started, and quite the opposite almost.
I'm still here, right? I'm still doing what I did for the last 25 years. So I must be doing something right, or not everybody at the time was really looking to pivot and move to the cloud. Everyone said that data centers are dead, or, oh, you're going to be out of business in 5 years, in 2011, 2012. 12 years later, I'm still here. So must be doing something right. And not everybody really wants to go to the cloud. And we see, even back then, I recall a client I had that they stood up a bunch of stuff in AWS at the time, and they wanted to pivot away from it. So they did a lift and shift then. Customers and end users now are doing the same. They're seeing cost savings. So I got some data, right, that part of it's cost predictability. 2/3 of those companies surveyed by 451 Research in December of last year, 2022, reported being billed higher than they expected. 47% said it was 10 to 20% higher than they expected. 25% said it was more than 30% higher. So folks are shifting loads out of the clouds and into the colo model or even in the bare metal model, mostly for cost saving.
So early 2000s, we were seeing data center density, footprint densities, 50 to 75 watt per square foot. Felt like most facilities were built for.
Yeah. I usually use the number of 80, but
fast forward, it was the new sexy to say 100 watt, 150 watt, 200 watt, 250 watt, and like the density per square foot started increasing pretty significantly. And at the same time, I can remember late 90s, early 2000s, late 90s, I worked for a .com, and we had a half a rack of servers co-located, and it felt like a lot. And there were people in the facility that had 20 racks. So it was the most equipment you could ever imagine in your life, like looking at it. And that trend seemed to go up a lot. Hundreds of servers, thousands of node deployed into public cloud, massive consumption of public cloud in terms of virtual cores. And then now we're seeing deployments coming back into data centers, but also still very large and very dense, sized in thousands of cores, terabytes of RAM, I should say multiple terabytes of RAM, different disk configuration. When you're talking to customers and they're evaluating these things, and let's talk about like that shift back from cloud into physical equipment in a data center. What are you guys seeing, and what are you seeing in terms of that conversation around density? And are people still chasing this? We want to put 33 kilowatt in a cabinet because that's just what we believe we're supposed to do. Is that, or how is that trending for you guys? And how are you managing that with your customers?
I want to bifurcate that. So there's two different kinds of builds now. In my view, there's traditional small to medium-sized business to upwards of large enterprise they're looking to deploy their infrastructure. Back in, again, the early 2000s, right, the usual MO was it's roughly a 3 kilowatt build, 3 kilowatts per cabinet. Over the years, we've seen that, and I'd probably say it's about once a decade, a little bit of a jump to 5 to 6 kilowatts cabinet. And now the standard is typically 8.5 kilowatts per rack. So you make the assumption of that's a shift from 80 to 125, and then from 125 to 150 watts a foot. We're seeing new end users that are looking for these AI/ML builds, and those are really the ones pushing towards 35 to 50 kilowatts a rack. They're hearing conversations where folks are asking for 100 kilowatts a rack, and those are special builds. We've got a new it's called Evocative. Can't really dive too deep into it, but effectively it's a block of 20 racks or so, and 24 racks, I think, with that megawatt of capacity built in. It's probably a deeper conversation we have on maybe another podcast down the road. But again, that's kind of the big shift. The reasoning they want to drop these high density cabinets together has to do with latency between the nodes. So they need to be within so many feet of each other for latency reasons. So it's 4 meters. But again, that's a very big, deeper dive, and we could run this pod for 3 hours talking about this stuff.
Well, I mean, we might just completely sidetrack onto this. I mean, I'm immediately thinking about the old Cray computers where they had a crescent shape configuration specifically for wiring between compute and storage resources, and it's like everything that's old is new again at some point. It's just how much time has to elapse before it comes back.
Right. Back from the old client server model, right? We're in some way shifting back to that.
How much of customer demand? I mean, so, okay, 1 megawatt and 20 to 24 cabinets, it's a lot of power and not a lot of space. And just knowing GPU consumption and knowing what goes into these things, I get it. I understand where these things are coming from. This isn't like you're co-locating and calculating 200 watt per CPU kind of builds, right? Like it's a completely different animal. How much of data center demand are you seeing today coming from the traditional space, as you said, like SMB enterprise repatriating I also don't like that term, but I'll use it, repatriating cloud workloads into a data center setting of some sort, whether that's them buying equipment or going into and looking at bare metal, or computationally intensive workloads, is AI and ML workloads coming across. And let me give you the second prompt with that one, which is, how much of that do you think is driven purely by a cost, and how much of that do you think is driven by performance or configuration of being able to gain access to things within the cloud versus going out and putting it onto floor space?
So just to kind of thought process here, from what I'm seeing on the request front, it's probably 60% traditional colo, as I call it, maybe closer to 70. We're looking at large builds for large end users that are looking to get into the AI game, if you would, or to build their own AI clusters. 30% is probably a bit on the higher side. It's probably closer to 25, I would think, but their repatriation's real. And again, I don't like that term either, right? But it kind of fits.
Don't swim upstream against marketing. Just accept it and kind of keep going.
Traditional colo doesn't fit for an AI world. It really doesn't. The push is to pack more into a rack, and there's physics, right? Like the physics wins. It's the reality of it. So some of it's got to be air cooled. Some of and that's typically on your network side. The push is really going to be eventually to be liquid cooled. I know that's weird, and those of us who have been doing this a long time, always want to fight the fact that you want to stuff water into a piece of electronics, but it's real. And it's simply a physics game. So we want to pack as much as we can in a cabinet, and we need to cool it. And the best way to do that is liquid chip. So we're going to get there. We're already there, really. But that's bleeding edge tech is what's driving.
But that liquid cooling isn't necessarily a design how much of that is a design that impacts data center and your footprint as a whole, or how much of that is just an application buying a specific thing and going out and getting a cabinet with compute blades or GPU blades with liquid cooling into it, and now as a data center operator you have to know okay, there's non-conductive liquid material in these cabinets over here in the corner, and be careful with them because you don't want that stuff on your floor.
You're not going to, at least we are not going to, on a traditional data center floor, going to run liquid to the rack. That's the reality. These are going to be purpose-built, designed with the expectation that the end user understands that there's water on the floor, right? This isn't just chilled water rolling underneath the cabinets. It's in large piping that's got sensors and stuff. We're literally plumbing it to the top of the cabinet, and the hoses plug in there, and the hoses plug into the machines, or the hoses plug into the rear door heat exchangers, and you're effectively grabbing the heat at the source and pulling it out of the rack and doing the heat exchange there. So they're going to be purpose-built. We're extremely nervous about blending that with a traditional colo environment, as we should.
Yeah, everybody asked me, after running data centers in Southern California, it was always are you afraid of the earthquakes? And my answer was, no, I'm afraid of smoke and water suppression firing off in these buildings. And the good old days of inert gas have long since left, and most building code requires you to have water in your data center. The pipes should be dry and all the other good fun stuff that comes with it, but I don't want to experience a water suppression system going off in a data center ever. So am I right? Did I write this down? Because you started by saying 60-70% traditional, but then large builds with AI, and then maybe 25 to 30% repatriation is the focus. So majority of demand at this point solely into traditional customers looking into AI and ML workloads?
Again, I don't have raw stats. I'm just going off of what my feelings are, right? I think maybe it's a little bit different. Maybe it's probably 60 to 70% traditional, 15% repatriation, and another 15% in AI. I think we're seeing more opportunities than we have in the past.
What's amazing about that number is how high the traditional slice actually is within that. From a cost standpoint and from a cost envelope standpoint, delivering 30 to 50 kilowatt per cabinet, even if the demand is a much smaller percentage of requests, the capacity and the actual consumption is so much higher. It's amazing how much AI and ML really drives that. And also, somewhat geography specific to industry, but also not necessarily industry specific anymore. This isn't just crypto miners going out and putting GPU farms out to try to mine cryptocurrency. You're talking lots of different segments. Have you noticed, or are you guys starting to focus on any specific verticals as a result of this? Or are you seeing more demand coming from any specific verticals?
Well, obviously the generative companies are out there hunting. And the challenges I think we saw through COVID, there was a shift from when everyone came to the conclusion that everyone needed to work from home. You saw a big push of we need to pull our machines and resources out of our offices and into the data center or into the public clouds. Then as things sort of cooled as COVID lessened, where we still live in a COVID world, and I think we're going to live in a COVID world or a flu world or whatever you want to call it for the rest of our days. Now we have a sort of a hybrid model where there's folks in the office and folks working remote or a combination of both. And so the shift is now to right size what we have, right? It's, do we run it in the cloud? Do we run it in the data center? Do we do a little bit of both? And with the generative AI groups, they're looking for, this is the latest and greatest. So to kind of package that all up, you saw a big push into acquiring data center space, whether it's the hyperscalers or we call it the holo model, right? Where it's colo and bigger chunks, right? North of 300, call it 300 kilowatts to a megawatt. And the hyperscale data centers were running around grabbing up every chunk of real estate, every generator, every piece of switchgear, all the cooling tech. And so through 2022, a lot of the available data center space got gobbled up. Now there's a big push into AI and everyone's like, well, we need to get 35 to 50 kilowatts a rack. Well, there's not a ton of facilities that are capable of handling that. So now you need to go in and retrofit what you have or build new. And it's, at one point, I think it was 64 months to be able to get a generator. So now all the space that's going to hit the market in certain areas, notably Dallas, I think it's already locked up. So even stuff that isn't finished being built today is already consumed. And then you have the AI push and everyone's like, well, I need 100 kilowatts a rack and there's no data center space available for them. So now we're seeing quote unquote retrofits or redeployments or what have you. And it's going to be interesting in 2024 as to what's available and where and who's going to win. And
I think this conversation is a huge disconnect between operator, large consumer, and let's say average enterprise buyer that maybe isn't actively in the market doing these things. And you see, we get capacity notes from facilities. Pick a market. Oh, we've got X capacity coming online on this date in this market, and we're selling into it now, right? Maybe this is 6 months ahead, a year ahead, 18 months ahead, whatever it is. And it's really interesting to see the end user reaction to that. And in some cases, almost like disbelief that we need to plan ahead this far with data center and data center consumption. And I've seen this now a bunch of times where, especially in really popular markets or in really popular facilities, an end user customer goes to expand and say, we want to increase our density or add cabinets or do these different things to it, and turns around and finds out the facility's full. There is no power left in the facility, and then they have to figure out what to do from there, which can create its own set of kind of, I mean, that when that wheel starts rolling downhill, I mean, it crushes all sorts of things. How do you work with end users as you're going through this and looking at these facilities and trying to plot capacity and demand? And years ago, it was popular for you to go out and try to negotiate a ROFR on space, right, or ROFR on power. What is the like right way for a customer to work with you and look down the horizon? Like, how many years out should they be looking? How do they track it? How do they, like, what's in your view as like best practices related to this?
I used to have catch-up calls with clients, or we call them QBRs, right? Quarterly business reviews, whether it's semi-annual or maybe annual, depending upon the size of the customer. And part of that is just checking in on making sure things are purring along like they have been, right? And they're happy, or they have challenges with things, but really it's us checking in on them on, hey, where's your business at? Where are you looking to go? Where are you looking to grow? And that would take place, I would say 10 years ago, and just find out, hey, figuring out what your plans are long-term, right? So you're sort of, I'm trying to space plan what I have, and does it make sense to expand the cage or cabinets, or do we need to look into maybe finding them additional cabinets adjacent, so forth. Now we need to be having these conversations more frequently, simply because there's such demand for capacities in our facilities that if I don't want to have to say, sorry, we don't have capacity, or we didn't plan for that, right? And so recently we had a facility in Silicon Valley that it's full, and we're going to have to add additional capacity to the data center just to support existing clients and their workloads and their growth. And that's 6 months, 9 months, 12 months down the road, but they've already committed to it. So here we are, right? It's a facility in 3 or 4 of our facilities in key markets they're at capacity. So it's difficult to have those conversations with end users. Like, well, I thought I'd be able to get another rack down the road. As far as a ROFR, depending upon the facility, sure, we'll provide them an opportunity to be able to grab another rack in some type of period of time. But at the end of the day, that typically going to get called earlier than the end user wants. So again, it's not a fun conversation to have, but it happens.
How does bare metal impact this? Are you seeing traditional users leaning into bare metal, or is bare metal dominantly a repatriation play?
I think it's some of both. I've got a client that we had conversations with starting last February of last year, and it was on a business review, and we talked about their renewal that was impending, and the conversation said they've got some workloads that are running in the hyperscale clouds, and they're looking potentially to save money on what that costs. And so the renewal gets done, but we're 3/4 of the way down the road on, hey, we want to run a proof of concept on seeing if we can run in your bare metal world and what that really looks like from a cost savings perspective. And it started the proof of concept just really kicked off, but the conversations are that that's going to grow potentially 10 or 20 fold if they can get their applications to run in that. And again, they run in Kubernetes, and it's a little easier for them to pull out per se than some other folks, but the math works. It's a 40% savings. So you again, business reviews are key, with whether it's with us or with whoever your operator is, and checking in periodically to figure out where you're at, where you're looking to go.
Let's dig into this. So bare metal now means different things to different people. I mean, my favorite thing with tech is it always, so many things get wedged into terms, right? Clustering. What is clustering, and can you define it? And the answer is no, of course not. So what does bare metal mean with Evocative, and how do you guys look at bare metal with your customers?
So again, it's similar to the public cloud world, right? It's a block of hardware that's allocated to you. It's got so many CPUs, so much RAM, so much disk per machine. I guess the major difference is it's not as elastic as what you see in hyperscale clouds, but I think it defines the block of resources you have available and creates cost certainty. So again, you have to size it to be appropriate to what your max capacity would be, but it also means you're not going to have the increases in costs that you would see in a cloud environment. So the notes I have on this said 47% of companies surveyed by 451 Research in December of 2022 said that their cloud costs were 10 to 20% higher than their budget. 25% said it was more than 30% higher. So it's a control thing, really. It's controlling your costs. Do you have a bunch of shadow IT instances that are getting spun up because an engineer needs, I need just a test bed, and so I spin up another DevOps box and with some resources, and they forget to turn it off? Or is it egress, right? I think that's a big push that folks don't really understand. When we're pulling data out of the cloud, how much does that impact our costs? So to me, we're defining blocks of resources that are available to you. It is not elastic as folks would want it to be. So you have to sort of budget and plan appropriately, not just dollars, but resources. We have 3 really different builds, call them small, medium, large. We're trying to keep it simple, right? Small box comes with X, vCPUs, X amount of RAM, X amount of disk. Medium's a chunky more, large is a little bit more than that. There's an extra large build. It's usually on an individual case basis. So again, these conversations come up, and you sort of have to size it appropriately. It takes a little bit of work, but again, customers are going to have more defined costs, and they don't necessarily need to worry about cost overruns or their budget going out the window.
So the dedicated server world of yesteryear, providers were giving you an operating system on top of a machine, and hopefully that machine was actually a dedicated box. How deep are you getting into management on bare metal? Because I'm asking this question because I find a lot of enterprises that are thinking about going down this road, but have never actually operated physical machines in a data center before, and are concerned about what the change is going to mean for them and how do they actually take care of these boxes. It's easy to say log into an AWS console or fire off an API request and provision an EC2 instance. It's a little different when you start saying, well, how do we install an operating system on a physical server now, because we've never had to do that before?
Typically, you give us the build on what you want from a hardware perspective and tell us what OS you want to run, right? And then there's a build sheet that we provide back to you that tells you how to log into the box. You obviously have to change your password and do whatever, and you're off and running, right? If you want to install a different OS version, that can be done via out-of-band management, but it's really simplistic. It's not as complex per se as the way years ago when you and I would log into a Linux box and have to turn everything off and configure everything and hand it off to a customer. I recall a conversation from 2003 when end users were asking for VPSs. And that's literally, I don't even want again, that's back early cloud work, right? Like I just want a Linux instance running on a machine, and I don't want to have to deal with hardware. And I think the cloud, from a staffing perspective, you've got a lost generation of folks that really haven't rolled up their sleeves and dug into hardware and dealt with it. A lot of folks, and not being critical of them, they came out of college and they just started coding into different cloud operators. And the idea with bare metal is it bridges the gap because you don't necessarily need to know about hardware, but at the same time, it fills the gap between what traditional colocation is and what running in a hyperscale cloud is.
So let's say focused on the repatriation side. Wow, I can't even say the word. I don't like it so much. The repatriation side of this conversation, because I think that's it's an interesting conversation to have. So enterprise turns around and they realize they've got this giant AWS environment or GCP environment or Azure environment, right? They've got a giant cloud environment. What are you hearing as the triggering conversation or the outcome that people are pushing for? Like, it's not, these things don't just happen because somebody wakes up one morning and says, I've decided we're going to close our cloud platform and go on to physical hardware again because it sounds fun and I want to put it on my resume, right? Like, that's not usually the direction those resume bullet points want to go. So what are you hearing from people in terms of driving this? Is this solely, I mean, is this firmly a cost thing where people wake up one day and just say, we're spending way too much money here and what do we do about it? Or are other things afoot?
Mostly it's a cost-based thing, right? If you look at what the artist formerly known as Twitter, right now X has done, they came in and they reduced their monthly cost by 60%, pulling out of the data centers they were in and things out of the cloud and moving it to where they had more control. A Basecamp, they've been very public about what they've done, shifting back from the cloud to the colo model. They're looking at savings, and this is, and you can find it, but they're budgeting that it's going to save them $7 million over 5 years. I mean, these are real dollars. There's we want more control of our data folks. They want to understand where their stuff is. There's the security folks. They are concerned with security of their environments and need to have more succinct control of it. So I would say the majority of it is driven by cost. A portion of it is a control thing. We know where our data is. We've been pretty open about your data, your business, your business, your data, right? Because again, have you ever dug in and read into what the user licenses are on anything, or is it literally scroll all the way to the bottom? Like, I don't know, right? And I'm not here to be accusatory of any of them, but
Jay, the cloud is secure. I just have to put my stuff there, and I'm perfectly safe now.
We've even seen a push for clients are worried about their backups, right? And where are they? Like, I think the days of going back to tape are real. Not everybody's doing it, but if your tapes are in a box, and whether they're buried in a bunker somewhere or sitting in a safe in another market, that's...
Compliance is an interesting one. You said control of data. When you say control of data, I immediately go to compliance with this in my head. And the examples that kind of like we're flirting around is what countries your end user data can sit in. And this is a big issue if you've got a global platform or a multinational corporation, right? Now we're seeing issues with jurisdictions down to state levels, right? States are starting to define and get a little bit more specific about what happens with user data and where it sits. So, and I mean, from a compliance standpoint, you said tape drives. I mean, immutable backups are a wonderful thing when used properly. Like, it's nice being able to write something out and have it be perfectly preserved and not changeable, and this wonderful little segment of time that you can rely on if you ever needed it again in the future. And I've seen a lot of that conversation happening as well with enterprises of looking for that.
Took a tour through the data center not earlier today, but yesterday, and walked by, and there's the tape run sitting there with a block of tape sitting in a cabinet, and there's a box where they're rotating them in and out. I mean, I'm not saying it's going to go back to the way it was 20 years ago, but tape didn't die. Tape's still there. Media companies love it because, again, they've got a backup and it's sitting on a tape, and they've got multiple versions of it going back years, and they can drop it in a vault or shift it to a safe in another market, and it's real.
Walk me through an engagement for a bare metal. And I mean, what I mean by that, it's like let's just use, you have an existing customer. You have an existing customer that has data center, and we're going to assume that they have a large cloud footprint as well that they moved into, and they've woken up on January 1st and said, we got to go the other direction with this. And so they call you up. How does that process work? What are the big milestones with it? What are the things that people should be ready for and thinking about? How long does it take?
Typically, so again, rewind to the client I started the conversations with a year ago. And it's really about sizing. That's the first step. Unless you can tell me what you need from a virtual CPU, memory, and disk perspective, it's difficult to really dig in. So whether they're reviewing what they have from a resource perspective or even looking at an invoice. And so the first step is sizing, right? Figuring out what you need to start, what you potentially need to grow to, and how quickly that is. The next conversation is, okay, what do you need from an OS perspective? And is there a license fee? And are you bringing your own, or do we have to acquire it for you? And then looking at the economics of it, like how long a term, right? If this is a situation where on a month-to-month contract, it's going to be more expensive, right, per se, than a 2 or 3 year term. And then there could be a test bed, right, where proof of concepts are there for you to try it out and make sure it's going to run your utilities that you need to run or your applications. And then the engagement is, again, it's a fairly large build, so we're 9 months in to when the conversation started. And there have been in-depth conversations with their DevOps and engineering teams all the way through. Proof of concept launches, we're midstream on that now. And they'll make sure that they can run their applications the way they want. And then there's a scaling conversation. How big do you want it to get and how quickly? Because, again, it's not elastic. So we're allocating blocks of defined resources, and we need to be a bit of ahead of the curve, so to speak. As you are intimately aware of, there's not just limitless resources available. You have to actually have to rack them and stack them and cable them up and make sure the network is going and burn them in. And so that takes a minute. So it's not an instantaneous rock and roll. We try to have metal available for clients to be able to spin up quickly, but again, there's defined resources. There's not a limitless number of servers. And again, servers, CPUs, and RAM configurations, they change, I want to say daily, but really it's more like a quarterly or an annually thing, and customers want to have the latest and greatest. We allocate 10 to 20% of failover so that an end user can box is misbehaving because servers die. It's not a perfect world. Components will fail. Fans don't spin perfectly. So if an instance is giving you hardware trouble, then we need to be able to reallocate your workloads to another instance. And that's really it. It's not, as everyone thinks it's complex, it's kind of simple. This whole business is simple, to be honest with you. I keep saying it all the day. At the end of the day, it's all a math equation.
It's funny for me to have these conversations because I think about it a lot from now, let's just say in the buyer's position, right? And so when we start talking about like what the buyer is going through with these things, you have enterprises that have never run data centers. You've got a finance team that has never been involved with data centers and hardware cycles. You've got technical teams that probably haven't been involved with data centers and hardware cycles. And that's very normal now. I mean, there's a lot of businesses that have started in the last 15 years that just never dealt with any of this stuff, or a lot of people that came into careers in the last 15 years that just never dealt with this stuff. And it feels overwhelming if you're in that position. And of course, I remember building computers, and I won't say when I started doing that, and it's almost the exact opposite for me. It's like, oh, it's no big deal. Go get a data center and call up Dell, call up Supermicro, do whoever you want to do, right? And have them ship a semi-truck out there and just put them in racks and turn them on and off to the races you go. It's not as simple as that either, but some parts it pretty much is.
Well, to you and I, it's not complex because we've done it, right? It's, you don't know what you don't know, right? And again, the lost generation, and again, I'm not trying to be critical. They don't know what they don't know. They haven't had an opportunity to deal with it. We're both probably going to Fry's and buying a bunch of components and building machines when we were very young men. I'm not a young man anymore. I can't speak for you, but it scares me.
I started working when I was 12.
So
I'm still very young.
I have still to this day a COM64 and an Apple IIe and Atari 800. Haven't got rid of them. They just sit in a box. But again, it's you don't know what you don't know. And there are times, and most recently I've had a couple where there are customers that they don't know hardware, and they've come in and said, hey, we need help. Can you help us? And we can help to some degree. Racking, stacking, our data center engineers do it all the time. Customer end users don't. Like, cabling is an art. You don't cable things appropriately and it's just spaghetti. All you're doing is taking a server that's supposed to last you 5 to 7 years and making it cook itself in 3, maybe 2. So
you gave me a stat earlier, and I'm curious, was this a stat that you've seen, that Evocative has seen, or is this an industry stat? And this was the 40% reduction in cost going from cloud to bare metal.
That statistic is based upon what an end user client that I've been working with for the last roughly year on shifting. That's our math based upon what they're paying today in the public cloud and what it'll cost to run it in a bare metal instance.
And this is pre POCs and hardware sizing and validation, or this is post POC hardware validation?
Post.
Okay, that's a big number.
There's more data than I have at my fingertips to be able to share, divulge. But we have done some additional research, and let me find it.
I mean, what's the reaction that you find when you are in that conversation and these numbers come up? Are people excited, upset? Do they believe it? I mean, it's not a small number. We're not talking about, hey, we're going to shift 10, 20% of your spend. When you start talking about we're going to change 40% plus of your spend and your cost to operate this environment, it starts getting into this like, I don't believe you territory pretty quickly.
Well, the proof's going to be in the pudding, right? So again, this is going to be based on how long are you willing to commit to infrastructure, right? If it's the shorter the term, the less the savings. It has to do with the size of the instances. So, and again, the instances you're running today versus running them in a bare metal configuration. Statistically, our product and marketing teams think that depending upon what you're paying today for transport of the data out of the hyperscale cloud worlds, it could be as high as 70%. My 40% numbers are conservative. The reality will be in what really can come of it, right? What really does it, you won't know until, right? So, but I've done the math, and again, this whole business is just a math calculation.
Data egress from these cloud platforms is such a scam. I mean, it's incredible what they're getting away with for. And what's even scary about that is knowing at the scale these platforms are running, what their actual buy rates are likely versus what just a large enterprise can go out and acquire bandwidth. I mean, and just saying like cloud egress cost is here, large enterprise buying here, real cloud consumption price is probably doesn't even, I mean, it's crazy to me how effective the industry has been at making that number so obtuse and so disconnected from the actual economic reality that they have for these things.
I will liken the invoices that I've seen to what a phone bill looks like or what our phone bills looked like 20 years ago. And you can't make heads or tails of it. It's just, you have to dig into it and understand it. Or a utility bill, right? If you look at your electrical bill, you get home and, well, what's this charge or what's that charge? Or, telecom bill, what's an FUSF charge? Well, at the end of the day, it's taxes. So I don't see taxes in those invoices. So again, I have to go off the data the clients provide me. In the case of the build I'm doing for a customer today, I actually haven't even seen their invoices. They're just giving me the raw data on what it costs them to run on a vCPU, and we budgeted and figured out what we could do the hardware for and how long term and what it looked like, and the math, it penciled out. A bigger build, a longer term, it's probably going to go higher. Again, get through proof of concept and make sure that their application can do what they think it can do, and then the other benefit is they get to now, if it's running in an environment that's just the East or just the West, and then we can throw in the other magic buzzword everyone's been talking about for the last 5 years, and let's move it to the edge. So let's stand it up in a data center that's closer to where our people are, our DevOps team, so that they can do their builds and sort of home, right? I mean, I guess we could talk about Internet of Things too if you want, but I mean...
God bless telcos and trying to create marketing demand for stuff that nobody actually really cares about. I mean, we get to talk about the edge because everybody's told us to talk about the edge. 15 years ago, the rage in data centers was carrier neutrality. And there was a lot of aggregator, reseller, arbitrage, tier 2 networks, a bunch of different people that popped up into the space. And this of course, was, I think, the tail end of the byproduct of tier 1 transit being very expensive and opportunities to address that in the market. And lately, there's been a lot of consolidation within that. There's been exits by different, what you would normally put into like that large tier 2, maybe tier 1 space. I'm seeing a changing mentality around this where I think the end users are less concerned with I need to be on XYZ network as my end all be all and just I need an internet connection. I think this is also a byproduct of cloud to some degree. What are you guys seeing and how are you approaching network as a strategy with customers? I mean, obviously with bare metal, I would assume, my mom tells me not to assume still, but that, I mean, are you getting into network strategy conversations with people with bare metal, or are you saying, hey, we're going to provide the network and you don't have to think about this and what's happening in the data center?
Some of both. So obviously we have carrier neutral facilities on site. We'll have a block of carriers that are available, anywhere from 8 to 15. We run our own network. Evocative network is robust and has multiple tier 1 providers, carriers. blended in with access to peering fabrics. We'll provide transport, whether it's MPLS-like circuit from data center A to one of our data center POPs B, whether you want a MPLS circuit or even a wave, a diverse wave if you like, take it both ways around a ring. Or you want to interconnect from our data center to, in say, Southern California to data center in Dallas. Again, there's the ability to take ports and we can virtualize channels. And I want a gig that runs from Southern California to our data center in Dallas, or I want to run a gig to a POP that's in downtown LA. These are, again, we have a robust network that we've built that allows end users different functionality. And we're not agnostic per se, but we are agnostic per se, whereby you want to connect to whether it's a packet fabric or a megaport or carrier XYZ. Again, try to be a one-stop shop and be complementary and be as easy as you want us to be. Right? We want to be the easy button for end users. So from a network perspective, we have all different flavors, right? And I think our network, comparatively to some of the other larger co-operators, is probably more robust. Again, I haven't done the Pepsi challenge. Again, now I'm dating myself to talk about that, but at the end of the day, it's what do we have at your disposal?
I mean, this just goes back to like starting my first colo. We had a 10 meg connection to Exodus. And I mean, it felt like the universe at your fingertips. And part of my old guy thing has become this rationalization of how fast networks and Ethernet have gotten. And I'm seeing a lot of 100 gig deployment transit links to customers where they're taking 100 gig or 2 by 100 gig for circuits out of data centers. And of course, for the operator standpoint, 400 gig and 800 gig is a reality and coming. And it always, I mean, that gives me every time I see one, it's just like, wow, like contemplating like just how much bandwidth that is and how much is actually being consumed and being used and how much is being shipped around. How has that impacted your data centers and customers increasing their port speeds with you? I mean, you're still seeing 1 in 10 gig as common interfaces. Servers seem to be standardizing on 25, 50 gig now. Are you getting a lot of demand for 100 plus gig interconnects with customer deployments, especially in these larger footprints, megawatt deployment of AI/ML platforms? Like how is that changing things?
100 gigs the big push now. You still have end users that want gig, right? And they're typically on the smaller side of the spectrum. But the bigger the deployment, more throughput they want. Typically, it's a 100 gig port. Or if they want to interconnect to a carrier directly, it doesn't make a whole lot of sense to run that through an MPLS circuit. So it's typically a 100 gig wave, and I'd say 90% of the time it's going to be a diverse wave. So we're going to give them 2 ports, and they're going to, whether it's a cross connect to carrier XYZ that's located in the facility, or we're moving it over to one of our other POPs. That's where we're going. I haven't got too much into the 400 gig world. Normally, you get into that world, it's here's dark fiber, and right, or we're gonna provision the circuits on our own. The bigger the end user, the more network centric and experienced they are. So you're not really handling those types of services, right? But I would say that we're probably in the shift from 1 to 10 gig being the standard now. 10 gig more often than 1 gig, and very soon we're going to be it's just going to grow tenfold. And I'm not doing it. I'm a firm believer that you just need to skip 40 and go to 100 because you're just going to burn the same tech anyway. So why give yourself another step you have to deal with in 3 years?
I mean, fortunately, with the 6500 and 7600 series cheese finally seeming to phase out for the most part, 40 gig isn't a big push in a lot of places anymore. I mean, QSFP on Nexus is still a thing, but most modern stuff seems to have finally moved on from that point.
I mean, I recall 7 years ago doing a build for a customer where 100 gig was the platform they shipped to, and the conversations were now, they're saying, well, we might go into bonding 200 gigs to get to 200. And my conversation with them is I would just go to 4, right? What's the point? All you're doing, it's a Band-Aid on them. Well, not a Band-Aid on a bullet wound, but...
Yeah. Well, I mean, you said it beforehand, it becomes math. I mean, at some point you look at what's the cost per port, what's the cost for the optic, what's the cost for the cross-connect, what's the power envelope of the optic and the port on the device. And then you multiply that across whatever period of time that you're running it, and then you compare that with the alternative, and you say, okay, does this actually make sense or not? I think that I think that part's always surprising for people, just how, going back to like how basic things are, like just how basic that conversation is, right? Like it's just, does it make sense? And what's your supply chain? And what's the cost per unit? and what's your sparing cost and what's your cost for power. And you put that on 2 columns of a spreadsheet and you look at them, and it's pretty obvious which direction you should go pretty quickly. I want to circle back to something. You talk about sizing coming out of cloud and figuring out, and you mentioned vCPU. vCPU is an obtuse metric. Amazon doesn't define, Google doesn't define, Azure doesn't define, Microsoft doesn't. None of these platforms define what a vCPU is. They don't define what their megahertz frequency is. They don't define what their oversubscribe rates are. They just you don't know what you're getting. So when you start this process and somebody says, we know we've got this fleet of these instances and this many vCPUs, right off the bat, like how there's some math in the customer's favor immediately switching into bare metal and physical hardware of just eradicating whatever's going on in the vCPU world.
Well, it's defined resource. That's the thing about metal. We're allocating you an entire machine. Use it as you wish. You can break it apart. You can oversubscribe it. So oversubscribe it on your own. But there's no noisy neighbors, right? And there's no oversubscription at that level. You can oversubscribe your box the way you want. But the reality is, I can't sell a chunk of your server to somebody else. I'm sold you the whole server, or at least you the whole server, if you would, right? Because at the end of the day, you're leasing hardware. You're leasing hardware in a confined environment in a data center world that we're managing the facility. And with the network connectivity already bundled in, let's say you need a cloud on-ramp and you need, so that you're going to run some loads still in public clouds, but you need an interconnection back to it. Again, this big factor I think here is to save egress charges. That's readily available to you. So whether it's a cross connect or a channel on an MPLS or wave circuit, there's no channels on a wave, but it's doable, right? Like you don't want to get into the world of where you can customize everything because it doesn't really work and it doesn't scale. But that said, there's ways to build bare metal instances to make your world easier.
I'm looking through my notes here. I'm trying to think if there's anything that I have not asked you that I want to get into here in the final moments of this. I'll ask you a prediction question. This will be fun. Let's say 10 years from now. What does this look like? I'm assuming that.
Wow. You want to know where we're going to be in 10 years?
I'm asking you. You've got over 2 decades of doing this. So you've seen a couple iterations of this at this point. And so based on your history in the last 2 decades plus, what does the next decade look like? I mean, closing out the 2020s, where are we with data centers and cloud and bare metal? And what does this business look like at that point?
Well, with 2 decades of experience, I'm going to say that data centers are still going to be here. We're not building them in 10 or 20 megawatt chunks anymore. They're building them in 100, 500 gigawatt configurations. I think Chris Crosby from Compass Data Center said the big AI push, and there are some other podcasts out there that talk about how many megawatts or gigawatts of capacity that we need based upon what NVIDIA is forecasting for AI builds over the next 3 to 5 years. There's not enough power in the United States electrical grid to support even what they're talking about in the United States, let alone globally. Nuclear power is clean. It's real. Everybody's afraid of it because it's nuclear. But somebody can deploy and package a small reactor in an environment and put it out where there's direct access fiber routes and inexpensive access to water for cooling. You can do that. That will be the push. Go nuclear. I guess we're going to have to go nuclear, or we're not going to stay ahead of capacity. And it's supply and demand game, right? If all the supply is consumed, then the demand's going to drive where we need to go. And if it needs the gigawatts capacity that everyone's claiming, then we got to solve for that problem.
So to regurgitate this. No, this is great. I actually like this. In forecasts from the chip manufacturer based on their demand for chips, drive a power consumption curve for data centers in the United States, which then in turn drive a capacity and resource exhaustion of capacity for energy generation, which then dictate a change to capacity generation, which is probably only solved with nuclear in potentially small reactors attached directly to data center campuses in purpose-built builds.
Yep.
Boy, that'd be fun.
Well, look at what's the big push for Ohio. Why is everybody pushing into Ohio now? It's because there's available power, right? Why did everybody keep building data centers in Texas? Because Texas has their own electrical grid and there's available power. I don't see California. I don't see us getting them to build more power plants here. So where's their power? Where's their cheap power?
Yeah,
There's nothing cheaper. There's nothing cheaper than nuclear power.
No, I agree. I mean, this is why Hillsboro became such a big deal. Cheap power. It was cheap hydropower. And I don't think the U.S. is going to build and dam up any rivers coming in the next decade.
No, the challenge is water, right? where do we have water? Where do we have available water, clean water? Or the big push for the data center project in Portugal because they were going to leverage using the water from the Atlantic. It's readily available. That's really what it comes down to. It's power and water.
I'm going to check in with this. Is going to be fun. I'm going to put a thing on my calendar, and we're going to have to do this.
And I don't know if I hope I'll be around, but I don't know if I'm pushing up daisies or hope I'm not pushing up daisies at that point. It won't be that old, but
I agree with the thought process because there's been a certain constriction of watt per CPU. There was a big explosion of watt per CPU, watt consumption per CPU. And then the chip manufacturers got smart and started focusing on performance per watt on their CPUs because, of course, that was impacting their customers' cost, right? And what CPUs were being selected. And this is probably a lot of the birth between Intel and AMD in terms of what processor selection. And we can talk about whether or not ARM becomes a big data center platform or if it's RISC actually comes out as a CPU platform for data centers or not, and what that power envelope of watt per watt per megahertz actually looks like. It's not the right measure, but these things just get, 10 years ago, if you told me that we would be deploying a 50 kilowatt cabinet, I would have laughed at you because
again, it's a physics thing, right? Like,
yeah.
At the end of the day, if you do hot and cold aisle containment in a data center today with the appropriate size raised floor and the appropriate size return air plenum, you can do 35 kilowatts a rack comfortably. Our builds in the Align data centers that I did back in 2017, 25 without pushing the envelope too far. Right now, the ask is 100. Everyone's asking for 100 kilowatts a rack. Again, it's physics, man. Physics made my brain hurt, so I didn't really dig into it too far. But smarter people than me understand all those better.
For those of you following along, we start talking about physics, and we won't get into this at all, but there becomes really interesting design considerations for plenum, and there's actual applications that model airflow underneath raised tile floors based on the support joists on the floor where your either supply or return ducts are related to that floor space, and how airflow moves underneath the tiles and it hits the support stanchions and then swirls and what you've yeah, okay. I'm glad I don't have to figure this out. I just have to be on the
It starts making your brain hurt, then it's folks that like physics, right? Like that.
I know. I'm glad I don't have to figure that part of it out. I just have to say we need 100 kilowatt per cabinet and go, where can we go find it and make it happen? Do you think, Sun Microsystems a long time ago came out with this crazy idea to put little micro data centers in shipping containers and put them on site and into the parking lots of enterprise users. And it went for a while, and then there were a lot of data center operators doing pod-based construction around these shipping containers where they were able to do rapid assembly, and these things were... Do you think that approach is dead completely? Is it going to come back, or are we going to see the resurgence of shipping for co-location with containers inside of servers and containers and containers? It's like container shipping containers.
Well, and then you have the floatable container that we're submerging in the ocean, right? The submarine data center pods, if you would. I don't know if the container, like you take a container and you're boxing in, if you would, right, the environment. And there's data centers that even in a warehouse environment that these run in today. So I think it's more of the modular part of it. I think you're probably going to see modular designs, and modular designs have been out for the better part of 15 or 20 years because it's again, you build to a box or you build to a contained environment. I don't think they're ever going to entirely go away. There are applications where it makes sense. Again, but it's back to power, water, or whatever your cooling medium is, fiber at that point. What's your connectivity to the container, if you would? What's readily available from an upstream connectivity to get to carriers? I don't say it's going to be dead, but big boxes built, designed to... Even the other piece of it, too, is like everyone says, well, why build my own data center?
Don't build your own data center.
No. Cost increases.
Don't do it.
There's two data points there, right? The cost to build a tier 3 data center as of last year, December 2022. I believe these are uptime statistics. It was $2 million, has risen by $2 million a megawatt. I think the number we've seen it's doubled since then. And that includes obviously a cost you got to go to acquire land, and you have to get power and water, and you have to get permitting, and you got to build the box. You got to wait 40 years for generators.
There's no world where it makes sense to build your own data center. I'm just going to put my foot down on this one. Just get fiber to a data center close to you and go co-locate. Don't build your own data center. Yahoo built what looked like chicken coop data centers in upstate New York, and that was a heat exhaustion. How do you exhaust heat without using mechanicals in order to get the heat out of facilities, right? So hot air rises, and you can create airflow and out the coop and have this natural convection taking place. I think it was, I'm going to mix up Facebook and Google here, started experimenting with hot aisle mist. So misting cold water in the hot aisles between their facilities. Now, users like Google and Yahoo or Facebook can create interesting designs because they control it end to end, right? They're building the hardware that's getting in the cabinets. It's everything end to end. And data centers with mixed use and multiple users have to be a little more generic, right? This drives a lot of like what is your PoE in a facility? Well, if you've got some people bringing in HPE and some people bringing in Dell and some people bringing in Supermicro, right? Like your PoE, there's a wall. Do you think there's going to be a day where the data centers become a little bit more prescriptive around the equipment, what equipment the end user can put in? I mean, how it gets deployed, what the build is? I mean, do you think that day comes at some point in the next 10 years, or do you think it's still going to be?
It's already here a bit to some degree. Again, you're talking about a common air exchanger, right? Exhaust the hot air out into the environment, bring in the colder air, because the delta T of having to bring air in from the outside that's at, say, 75 degrees in Southern California as an example. You only have to bring it down to 10 degrees or what have you. Or even then, based on ASHRAE standards, oftentimes you could just bring in the air and you just have to exhaust out the other air. That's in place today in a lot of places. The new build environments in what is now an AI world, and I haven't cracked the Skynet joke yet, so I'm not going to, but the AI world, we have to go to water. And again, I'm not saying that we're going to go out and use a cooling tower and boil off gallons, thousands of gallons a day. That's not it. We're talking a closed loop solution to just do the heat exchange to the plant that's outside, the chiller plant or what have you. So we got to build to that. And that's going to be, again, we're going with a modular configuration. We're focusing on the densities that we're being asked for today and the densities that we know are coming in that environment. Now, traditional colo, you can probably retrofit some of it to some degree, but again, you don't want an AI client with water to the chip next to a client that's running Dell and HP gear at call it an 8.5 kilowatt stack. So, and again, things traditionally have gotten smaller, right? Back to the days of 20 years ago where I'm building a 4U rack mount box with a motherboard, 3.5 inch, what were they? What was the size?
3.5 inch, yeah.
3.5 inch drives that were 9? SCSI 3?
Oh God, SCSIs. 9 gig SCSI.
9 gig SCSIs, right?
9.2 gigs. Seagate 9.2 gig SCSIs. Yeah,
Yes.
those are the hotness.
Now I'm dating myself. I probably dated myself.
Well, no, you just said you put it into a Sun D1000 storage array, and then you'd be dating yourself.
I still have the Spark 10.
Man,
we haven't got rid of it yet. It's in storage. I'm going to turn it into a coffee table at some point, or an end table for the couch. It just needs 4 legs. Plug it in.
Oh, it's fantastic.
Let's run Sonos.
Yeah, E450s rise from.
I was thinking about those the other day. I remember
boat anchors.
I remembered I broke my arm putting one in a rack once. They were not.
If you don't know what an E450 is, an E450 was a very popular Sun server from the late 90s. I think they probably came out like 97. And it was a multi-processor chassis, multi-disk enclosure chassis, and it was a cube. And it was 19 inches wide and probably 23 inches tall and 20 some odd inches deep. And it weighed it was solid steel. I mean, this is back in the good old days of Sun building stuff with like 1/4 inch thick, just sheet metal for the enclosures. And
back to you quoting a 6509 chassis earlier, right? Or 6500 chassis. It was the same size as a 6509. It's about 14U.
Yeah, and they weighed a ton, and we called them boat anchors because you could attach a chain to it in the water, and it would probably keep your boat in place. Jay, any last words? Any last thoughts that we haven't gotten to? I got sidetracked here,
and you're probably going to have. We may need to have a follow up to this because once I kind of cogitate on what we've talked about today, I might have follow ups. But no, it's been fun.
Yeah, Jay, thank you very much. It's always a pleasure. Love our chats and love talking about data centers. They're never. I agree with you. Data centers are never going away. I don't care who's forecasting what. The cloud lives in data centers. By the way, if you didn't know that, the cloud is in the data centers. The data centers don't go away.
I try to explain it to my kids, and that was 10 years ago. Dad, what's the cloud? Well, Dad just serves clouds, guys. That's what Dad does. He runs data centers for people to run their clouds. It's not actually in the clouds. no, it's not up. So
The cloud is in my data center.
yes.
There we go. Well, Jay, thank you very much.